Thanks, Weita, for the introduction. So this is a study of a chatbot we deployed in IBM to answer employees' questions about IBM. So chatbot, conversational agents, you probably have seen them a lot around recently and become kind of a media buzzword. But they're not new. They can be traced back to more than half a century ago with the invention of ELIZA. And of course, academia have worked on many prominent examples of conversational agents. And given this history, it's surprising that we still don't know much about how people talk to conversational agents. At least that's the case when we wrote the paper. I'm seeing a lot of paper coming out this Kai. There are many reasons. The early system, they're mostly system initiatives. There's simply not much room for users to converse freely. A lot of them are developed in the lab, so there's not much user data available. Recently, a lot of systems are adopting the real world, but there are proprietary reasons we just don't have access to that data. So while we are developing and deploying chatbot in IBM, we want to take the opportunity to study how people converse with a QA chatbot in the wild. We start with a very simple question. What do users say to a QA chatbot? By QA, we mean the model of user initiative. User asks a question, the bot answers something, and this is the model of popular agents like Siri, like Alexa. This kind of model poses a particular requirement of anticipation. You have to anticipate what your targeted user may say to the chatbot. Without that, it's very easy that user input will fall out of scope, and the only thing your chatbot can say is, sorry, I don't understand. So by looking at the chat logs, we want to do descriptive analysis and provide some pointers to other people who want to develop QA chatbot. Another question we ask is, what kind of conversational interaction can be used as signals for user satisfaction? And our ultimate goal is for an adaptive system that agents can adapt its behavior based on whether users are happy or not. But that gets into a tricky problem because adaptation should ideally be based on the user's internal status. But our conversation behavior should be seen as signals of our internal status, and sometimes the signals are less reliable than others. In other words, how do we know what users really feel if they say something? If someone says, shut up Siri, are they really unhappy about system and want to stop using it? It turns out this is a common problem studied in computational linguistics. And of course, there the focus is more on the kind of social status when people talk to the other person. And a common method they use is statistical modeling. In one example, just in Crasso, they went to study how people talk to another person. Then afterwards, they asked them to self-report how much they like each other. And they use that as a ground truth to build a statistical model. And they try to see what kind of conversational behavior, what kind of pattern can significantly predict that likability of each other. So those can be taken as more reliable signals. So we generally follow that kind of approach to build statistical model. But since we're not looking at talking to another person by using a system, we're going to look at two critical dimensions of user experience for chatbot, which are functional satisfaction and playfulness. So functional satisfaction should be straightforward. We're looking at a QA chatbot, so we're looking at how satisfied with the information assistance provided by the chatbot. This is very close to a concept of behavioral signals as implicit feedback in information retrieval research, which also points to some solutions. If we can identify that kind of different user, how the system should adapt. If someone is less adept, you can change the algorithm, you can give targeted assistance. And playfulness, I will point you to the paper for a longer review of literature. What do we mean by playfulness? We probably have a very different definition with some of the gaming research here. But I think the most representative one is from Luger and Salem. So they did a qualitative study of how people use things like Siri, and they brought up this concept of playing as a point of entry by asking random questions and looking for humanized and humorous answer, given that the chatbot is based on a human metaphor. So this paper and others show that playfulness is actually critical for the adoption of chatbot. And we have done a study 2 years ago. We show that there's also individual difference, that some people do seek satisfaction from playfulness, and we show that they have very different set of design preference. So without diving into this long list of prior work, I just want to say where this work is situated. So when we think about adaptation, there are 3 questions. The first one is what to adapt for, and based on literature review, we're looking at 2 dimensions of user experience with the chatbot that are functional satisfaction and playfulness. And the previous work I just mentioned, they gave some suggestion on how to adapt. But this study, we're really trying to answer the 3rd question, which is for whom to adapt. How do we identify people who have different level of satisfaction, who have different tendency of playfulness? It's not realistic that we always ask people to self-report. So we want to identify some reliable signals for that in conversational interaction. So that's the goal of this study. So having said that much, how does our chatbot look like? I'm showing you some user interaction episodes here. So we developed a chatbot called Chip. Don't ask me where the name comes from. So IBM employee, they can add that chatbot on their enterprise instant message tool. They can start asking a question at any time of day. For instance, in this case, the person is asking, tell me about healthcare benefits. The example on the bottom right is an example of playful interaction. It's asking, what's up, Chip? What do you do for fun? And the one on the right upper side, I want to point one thing. Sometimes Chip cannot answer your question. In our deployment, we ask participants to use #fail to give feedback. This is completely voluntary, but we see that a lot of people actually did it. I will come back to that in the results. So the data I'm going to look at is from a deployment to 337 new hire. They came to IBM. They used Chip because they do have a lot of questions about the company process, and then they use it for 6 weeks. So I'm going to look at the chat log. I will focus on conversational interaction. I gave a loose definition here. Those are utterances performing communicative or social function. I use quote unquote because by social, it's not necessarily the same meaning as socializing with another person. In other words, I'm actually excluding utterances that's just performing QA queries. For instance, I will throw away those 2 questions because for one, I'm looking at conversational behavior. For 2, they are very domain specific, so they are less interesting to look at from a generalization point of view. So to look at a chat log, I'm actually not interested in how often, for example, someone say hello, but instead I want to look at a higher level category. Some people will say it's conversational act or speech act. Practitioner may call it intense. So for example, if someone may say hello, hi Chip, good morning, those utterances are all performing the function of opening. So I will look at that categories of opening instead of individual utterances. So how do we get that categorical label? Actually, the whole system is developed based on a classifier that will classify the utterances into those conversational category. I know you have a lot of questions, but I will point to the paper, how we develop those category, how we train the classifier, how we did the data cleaning. But try to suspend your question now, just see that I'm not looking at individual utterances, but looking at those conversational categories. Another question is how we obtain the ground truth, right? We want to model to predict functional satisfaction and predict playful. So after the deployment, we send out a survey to ask the participant to self-report functional satisfaction, where we ask questions around QA function, including understanding, relevance, answer quality. We ask them to report their playfulness. But based on the literature review, we focus on 2 questions. One is what we call sociality. I enjoy just chatting casually with a chatbot. And another is off-topic desirability, because we are thinking about playful, which are not to serve the intended function. So I actually enjoy her things that's unrelated to IBM. So we collect those self-reported rating, we average them. This will become our ground truth when we build statistical model. So now let me jump to the results. First question is, what did the user say to chip? And we want to perform descriptive analysis on those conversational categories I just mentioned. So we identify 13 categories. We report on the percentage of messages, the percentage of people who have ever said that. I'll jump to the kind of takeaway message in a bit, but you may ask, how do we know it's generalizable? How do we know it's not specific to the chip use case? One thing we did is we try to compare the results to what's reported for another conversational agent. Although limited, we did find this one paper from Kopp et al. They reported the interaction statistic for a QA agent deployed in a museum setting. So we tried to reach the conclusion that holds in both cases. We had some detailed analysis in the paper. But to conclude, we find that there are 4 main areas of conversational interaction for chatting with the QA chatbot. The first one is to give feedback. This includes complimenting the chatbot, complaining about chatbot, and also this formal way of #fail. It's interesting that more than 40% of people did give that kind of feedback. The second one is chit-chat. Those resemble how we have chit-chat with another person, like asking about the agent status. How are you? What's up? And asking about agent traits, like what do you like to do? Who developed you? And the third one is what we call understanding system. So those are questions to check the capability of chip. For example, what can you do? Can you do this function? Do you know this word? Even though on the surface it's still a humanized question, they perform very different function. They want to understand what chip can do. The last one is communicative utterances, including opening, closing, acknowledging. You see that that's actually happened a lot. For around half of people have done that, except for closing, because we have a chat window. A lot of time people just close the chat window, not explicitly closing the chat. So now we have these 13 categories of conversational interaction. We want to know which of them can be used as signals to predict functional satisfaction and to predict playfulness. And we use statistical modeling. So I don't have time to go into the detail. The modeling method we use is what's called lasso regression, which is a type of penalized regression. You can understand as a regression analysis without worrying about the problem of collinearity. Because we are going to throw in a lot of variables, and some of them are by nature correlated since they're language behavior. So lasso regression allows you to not worry about that. And we built 2 models, one to predict this functional satisfaction, one to predict playfulness, and we include the same set of predict independent variable. And we have 2 groups. One is this 13 categories of conversational interaction. We also throw in the raw text feature, the occurrence of single words, double words, triple words. We throw away stop words and the domain keywords following the kind of convention of text analysis. I do want to mention that we control for success rate, because different people may have different success rate. So we're looking at, given objective system performance, the variation in your subjective opinion. That's the definition of different user profile when we think about adaptation. So in the paper, I have this big table of statistical results. I'm actually going to skip it, and I will jump directly to the takeaway messages. So what signals functional satisfaction? We identify 3 themes. The first one is that we just mentioned that there's a lot of feedback given in conversational interaction. And there are both opportunities and caveats. We see that this formal way of #fail, they are very reliable signal. The more people say it, the less satisfied they feel eventually. But complimenting this agent saying you're smart, or complaining saying you're stupid, shut up, those are not reliable signal for satisfaction. Instead, they're more associated with playfulness. People are just playing with the agent. The second interesting thing is that we see some conversational interaction can be seen as an implicit way of expressing frustration. One category is this checking agent capability. Can you do this? Do you understand this? So a prominent problem with a conversational interface is that the affordance is bad. You have problem understanding what exactly the agent can do. And when people start explicitly asking it, it can be seen as expression of frustration. And similar for closing the chat saying, bye, I will go now. Those can be seen as, I'm going to stop using you now. The third theme we find is by looking at the lexical feature. We see a lot of positive predictor that can be seen as a formal way of asking question, like where, how do I, can I. That's also understandable that people who are happy about the QA function, they may use the QA more, so you will also see the occurrence of those formal pattern. And then what signal playfulness? We also identify 3 themes. Probably to be expected, the kind of chit-chat, asking agent status, asking agent traits, talking about oneself, those are strong indicator of people being playful. But it's interesting if you see that in contrast, things like opening, closing, acknowledging, they are not reliable signals. So this can be seen as more of a habitual utterances because people are using this chat interface they normally use to chat with colleagues. And the second thing is that we show that playful users take an interest in the agent. As I mentioned, they compliment the agent. We also see a lot of questions about the agent. So it's possible that just by tracking the usage of second pronoun, we are able to identify those playful users. And last theme is that we see a lot of casual testing. If we look at the kind of lexical feature, things like do you know, tell me. And also they have used a lot of the word search. And when we go back to the chat log, we see that sometimes they just keep asking search about my manager, search about my colleague. So that shows a kind of playful testing interaction. So to summarize, takeaway messaging, we identify 4 areas of conversation with QA chatbot: feedback giving, chit chat, understanding system, and the kind of habitual communicative utterances. We also show that to answer the question for whom to adapt based on behavioral signal really requires empirical analysis. We need to find that there are rich signals in conversational interaction, but they deviate from human-human conversation. For example, complimenting the agent, you shouldn't be just taken as satisfaction or happy about the system. We also show that it's still important to think about how to design for playful users because they have very different patterns, they're going to ask different questions, and they're going to keep testing, do this random testing with the system. So it's important to think about how do we design that kind of humanized response, but still communicate the actual system capability and to ensure the system robustness. So with that, I'm concluding my talk, and I'm happy to take any question. Thank you.
Hi, I'm Julia Brich from University, and especially regarding things like the compliments, I was wondering if you had any trouble with users being ironic or sarcastic.
So I believe that definitely happened, but in this level of analysis, when doing statistical analysis, it's hard to come to that level of detail. Mm-hmm. We are doing more of qualitative analysis, actually trying to look at different examples and trying to understand that. But I think in this study, in this analysis, that's probably just simply not able to answer that question. So that relies more on the kind of conversation analysis or qualitative content analysis.
But was it possible to just leave out that level in your analysis and just focus on the lower, on the literal level?
So we did throw in, what do you mean by literal? So you want to look at a lexical feature?
No, I'm more interested in how did your analysis exclude that kind of thing, knowing that you couldn't tackle it?
Right, so one of the reasons is because we don't have enough data. So we had to abstract the level a little bit and then trying to throw in this categorical feature. If we have a lot of data, of course, that kind of signal will come up better. But again, we only have a few thousand of data, so that's limited by whatever we have.
Thank you very much.
Thank you.
Hi, Karina Rambida from University of Waterloo. I have a question about have you considered some type of interaction like voice interaction and how would that affect for example, playfulness. So if you choose a male or a female voice, different accents, how would that affect the interaction with the users?
Right. So of course, that's a good question. When you have more modality, you have more ways to be playful. I'm sure you have the tones and everything, but then that also change if we are building statistical model, trying to see that kind of behavior signal, what kind of feature, what kind of representation we want to throw in, right? So instead of throwing text, we might throw in also the tone, the tune, and those kind of things. And I'm sure you will be able to identify certain signal at that level. So that's a question to be answered, and would be interesting to see that result as well. Thank you.
Thank you.
Hi, Eric Balmer, Lehigh University. IBM employs a whole bunch of different type of people, right? Like you could have people who work on Watson interacting with Chip. You could have people in sales interacting with Chip. So I was wondering how different users' mental models or expertise play into the ways that they interact with the system.
Right. So that is in our limitation session. When we do the deployment, we try to recruit people in different departments, but one caveat is they're new hire, so they're certain age group. So you maybe see people are more playful in that sense. So that's in our limitation session. But I think there are a lot of factors, demographic factor, expertise, domain, will impact how playful you are. And of course, you probably can see people in the business sector maybe more uptight and don't want to play with agent. That's entirely possible. But taking it as a case study, we don't know. So.